Hello everyone, this is Pranava. In today's video, we'll be going through another challenge of MetaCTF. This is going to be a challenge from April 2024. This is a binary exploitation challenge. So let's dive in. Coming to the challenge, it says check out my L33T speak converter. It helps me talk like an internet nerd. Connect through a NC with the netcat session and you can download the binary here. So let me download the final binary file. Yes, so save. And then let me copy this command. So copy, then I'll open up my terminal. So here, let me zoom in. Then I'll paste this command here. So, okay. So, okay, I guess my network, either my network is down or the server is a little slow. Okay, enter string to lead Speakify. I don't know. I'm not able to pronounce it, nor am I going to even try to pronounce it. Hello. How are you doing? Hello, how are you doing? Okay, H-E. Hello, how are you doing? This is how we, I guess we write our hacker names, right? So if I write as hacker, this E is going to become 3. Yeah, cool. Okay, so it's basically converting the input that I give, and then it's going to just present it here along with some kind of process of converting A to add character, E to 3, and maybe whatever that is. Okay, so fine, that looks good. Let's go to the downloads folder where I have downloaded the executable file, and let me clear my terminal too. So ls, and I see my file to be here. So first thing, let's look at what kind of file is this. The file and then the program or the file which I want to look at, the file type. I can see it's a 32-bit executable file, and then dynamically linked. Okay, that's fine. That's good. So that means the libraries and those things are going to be used from my computer. Then it's a stripped function. Oh, okay. Fine. So the strip function basically means that I can't use two softwares or tools like GDB, which is going to help me to disassemble the program into assembly and then look at the way how the program runs at the system level or the root level at or the stack level, and then break down the program using break functions and those things. So I can't do it using if there's a stripped executable file given to us. That's fine. We might have another way. But we see this that it's a 32-bit executable file. Actually, while you're exploiting or working on binary exploitation or something where it's new, it's always recommended to make some notes along the way as you understand the challenge basically. So let me copy this about file. Let me put it as about file. I usually do all my notes using Obsidian, but right now let's do it in this itself. About the file, and I will enter. This is a 32-bit executable file. Then it has dynamically linked, and then it is also stripped. Okay, so all those sensitive, like all the main functions and those kind of variables are all removed from it, right? That's why we can't disassemble them in GDB or tools like that. So those function names are all removed. That's fine. That's still okay. So there's nothing else in this. So if I use the tool called strings, let's see what's there. If we can get any file or things like that in it. So TDL, okay. So so they're using printf, okay, it's fine. F open to open some file. F gets to receive input from the user. Okay. Flag.txt. Okay, there's a flag.txt file. Okay, that's good. Maybe the flag.txt is stored inside this executable file. Maybe I don't know. So unable to open the flag.txt. Okay. Enter the string. This is what we saw, right? This is what enter the string to lead. then original input, then okay. So all these are the one which are dynamically linked. And, okay, we also see GOT, that's global offset table, right? So which uses, like, if there's a printf function, it's going to use all these things for printing those conditions. Okay, that's fine. And we still don't get the flag. I just want to try by entering some long characters into this file. So lead. Okay, I can't run this file. Okay, I just need to give it permission. So lead. So now I should be able to run this. Yeah. What will happen if I give a very long character into this stack? Will it overflow into something? No, it did not. Okay. So there could be some buffer overflow, but not just directly through this through this input kind of variable. Let's open a tool called Ghidra. This is used for basically a reverse engineering process. If you given a object dump or something, or any dump of the file, oh, I can even show you that, right? So object dump, this is going to show the contents, or it's also going to break down the tool or the executable file, but it's not going to be still having any interfaces or anything like that. It's just going to dump out the file contents of it, or basically how the tool is built or is visible in the assembly level. It's just going to display that. We can't, it's really difficult to analyze in this despite this, because it's a huge program, I guess, and it has a lot of other functions in it. So let's not use this, but instead let's use a tool called Gita, and let me open the file. So click on new project, next, and then the downloads folder, that's fine. Let me name it as meta CTF, finish. So this tool is used for a reverse engineering process. Like, you have an executable file, and then if you have the object dump of it, the dump of the assembly level programs or the memory address of the stack, you can, using those things which you get from the stack or the memory, it's going to try to make a suitable code which could have been the possible code of the program. So it's going to generate that. It's going to help us in analyzing this instead of just looking at the memory bytes and then looking into it, because I'm not into that level of doing the reverse engineering or binary exploitation. So I will copy this file, delete the executable file, and then drag and drop it into this. So that is going to select that one under this MetaCTF folder. So click on OK, and then it's going to import our file. It's going to show all the summary of just the file, what it got before analyzing it. So we see the program name, language ID, the compiler which was used, GCC processor 32-bit or x86, and it's using little Indian formatting of the process or the memory address kind of thing, where the least significant bit is given the first priority while assigning it to the stack. And then the address size 32. Okay, so it's all the information what we saw from the file command. So I'll just click on OK, and then double click on this lead file, which is going to then analyze the code for me and then going to present me with it. So it has not been analyzed. Would you like to analyze it now? Yes. And then analyze it. I'm just going to go with the default arguments. What is that? Okay, so this is what is our dump, right? What we saw from object dump. These are the same kind of thing, but the unique factor or a good factor about this is if I click on any of these um, memory address, I'm going to get a code associated with to that memory address right here. Okay, now let's get into a little too technical of this process. I can see something called as process entry, or this is the entry point of the program. So this is where the program actually starts with. um okay, we see it here. So entry of the program. Okay, this is not that much useful. If I go through by clicking each address, it's going to take a lot of time. So what we can do is, since I already, while I ran the command strings, we saw flag.txt and such kind of strings to be easily available, right? So we can use the same thing and to directly go into those memory address and then look into what we want. So I'll click on the window option and then define strings. So it's going to open here. It was already open. Okay, fine. I'll just close one of the tabs. And here we see all the strings, and these are all the offsets I told, no, GOT and those things will all be visible here. Okay, it has done a lot of analysis. I opened defined it. I don't want this. I want window and then define strings. Okay, so here we see all the strings that we saw from our strings command. Okay, and we also see the flag.txt here, which is associated with this memory address or the location. They say it here. I'll scroll this a little this side. We see the memory address, which is having flag.txt in it, and an associated or referred function. So this is going to be the function which is referred to it. I clicked on it. I would actually put this into my notes because it will get too complicated. I'll just copy this. I'll copy this address and make a notes here. Ira. Then this one, yeah, it took it, and that had referred to this address. No, so let me go here and then copy this reference code. Copy and then paste it here. Yeah, I don't need all these things. Let this be there, but I don't want the hexadecimal characters. I mean, it's useful, but not right now. And it's referring here that code is here. Okay, good. So let me go to this memory address now. Just right click on it and click on decompile window. So that is going to, let me open this little much. So it's associated with this function. That's why we have this function given here, and this function, that's file int character local, all those fine. Okay, so we see that the file.txt is being imported or opened in this function. So if this stream, okay, is comparable, if there's some error, unable to open the flag. Okay, so okay, let me just take a moment and then explain what is exactly happening. So we saw a string file or the string window in which we saw a flag.txt file being referred, right? So we went to that address where it was being referred. From there, we got another reference point which was given to this location. So in here, under this function and the memory address, okay, there's a file being opened which is our flag.txt and it's going to be saved in this location. That's what is happening here. I know I'll be using a lot of this, that, and then references here because I don't want to be reading this long address and then confusing myself as well as extending this length of the video. Okay, so please bear with me if I use a lot of this, so, and other kind of words. Fine. So let me copy this address also. I'm actually becoming conscious with what I'm saying. So yeah, this is the memory address where the flag.txt file is open. So we want to read this file. If I'm able to read this location, no, I'll be able to read whatever the content is there inside the flag.txt. So that's one thing that we need to remember. So let me scroll down a bit and move to the next function here. So this is another function. I'll click on this memory address and I see this function to be doing puts enter a string to lead, and then it's going to be getting the input from the user. Okay, that's what we did here. No, so let me make this window into half and then one here. So when I run this tool, okay, so first it's going to store the flag.txt file into a memory address, and then it's going to be printing with enter a string to lead. and that one, and it's waiting for my input to be presented. So hello, so this is what it is waiting for. The press enter, it's going with the other thing, so it's not specified in this function. Maybe it's the next function which we need to be going into. Another function, I click on this. um okay, this is importing all of these things. Nothing of that useful. I mean, that's useful, but I can't read it exactly. And then this is also some kind of another function which is happening. We get a new function now. I guess this is the main part of it. Yeah. So okay, so this function what we got now, this address, it's the main function of the code. How I can say this is because one is containing all of these, and all of these huge code part of it, and all these variables are is usually given to a main function itself. So this is the main function of our code. So I'll write this as my point, main function address. That is saved here. Okay, so let's analyze this main function. Now these are all the functions which it is doing of character, bringing it, importing it, and all those things. So you can ignore most of the part in this, because no, in binary exploitation, the some of the information are going to be not useful to us, because the compilers are going to be inputting those characters into the binary file, which we can't anyway understand. Let's just focus on the place where the codes are written, where we can try to exploit or do something like that. Right? So we're just focusing on that part of the code, or that part of the process of understanding and analyzing this binary file. We see another function called puts, which is going to say original input and then new line character. That's what we got in here, which says in original input, and then it's going to be printing out the content whatever I entered as the original input, and then lead speak. Okay, and then it's using a printf function to print whatever I entered after it got through a processing of it. Okay, that's good thing. I don't know if that's really good, but fine. They're using a printf function to do it. Uh, actually, my mind is saying that there's a vulnerability in printf, which I want to come back in a moment. But let's analyze the code further, the binary file further. So just clicking on all of these function headers, and okay, that's it. That's it. That okay. So this was the end of our code. Here it's all the other variables and other thing which the compiler enters. So none of our use. So I was telling that about a vulnerability in printf, right? So what I'm thinking is, see, whenever you use a function like printf and then specify with a variable like that, if you look at the man page of printf here, man3 printf, you can see that in a integer type of thing, we can enter a constant, the character, and then restrict all those formats. So basically, in a summarizing, if you read through this document, you can understand that you can specify something called as a string formatting. For to give you an example, in Python, basically, if I want to print something like print, and then I have something like hi, and then I want a variable to come in here. So I'll say variable AB or AS, and then I give a comma, and then give on with the other kind of a string. Hi, my name, how are you? Okay, so we are breaking this program into pieces and then assigning or inputting the values into it. But using string format, what happens is, instead of me saying that hi and then adding concatenating contents into the program, I can specify a location or a place where it is going to, by default, put in these variables into it. Like in Python, I can give a flower bracket and then go further and specify with what I want in the what I want the contents to be inside the flower bracket using a tuple, right? So this can be done in a Python. So this is also there in Java, it's also there in C and all those things. So printf function here is doing something similar to that, where it's the input which is going to be given from the user is going to the function, and then it's going to be printed back into it. So if it's the variable which is being printed, so what I can do is I can try and exploit this string format vulnerability, right? So if I'm sure we need to enter one special kind of a character to get the data from the stack, I just want to try it. So let's Google search on string format, string format exploit, format string attack. Okay, not string format, format string attack. So here you can go through the description here and understand how and what these things are about. But just sticking to the challenge, if I yeah the percentage x. Okay, so if I use this command percentage x into the program here or the input section, and while printing out percentage x is going to be giving out the content or the data which is stored inside the memory of the file or the program, instead of just printing out as percentage x. I can show it to you here. So slash lead, and then I enter percentage x. I can see the output coming as 3. So that is the value which is stored inside the stack of that program, right? Okay, so with this information with us, I want to check and see what is the limit, and when does these, if I give any repeating character, if can I see any sequence of those characters being stored in the stack. Okay, I'm just trying to give a understanding about what could happen in the later stage of this. So if I give AAA, okay, and then if I give percentage x, and then dot percentage x dot percentage x, and if I do this for some number of time, it's going to start to display the contents of the stack once it crosses its offset limit. Okay, so I can see AAA and then 4C. This is some, from here it's some kind of thing inside the stack. So every time a dot comes in, I can see that that is one limit of or the bit of it, or the basically the process where, or the offset kind of thing. And here I can see it start to repeat with 414141, which is A in hexadecimal, and then I can see this being repeated here, 2525E 7825. Yeah, so this is being repeated here, so which means that these are all the percentage x in hexadecimal being shown here. So it start to repeat itself after some number of time that we did it. No, so let's count it: 1 2 3 4 5 6, and from the seventh time it start to repeat itself from the offset. Like of every dot there's 6 limits here. After that start to show itself in the stack, and it's repeating, so which shows that this is vulnerable to the format string exploit. Okay, that's good. So all that we now need to do is somehow overflow our value into the stack, where every time it's going to try to print the content of our input, instead of it printing this value here as 414141 or whatever that is, let it go through the address of the place which I want the file to be printing. For example, I wanted to print my flags.txt file, so that it's already open now, so we can tell it to print the contents inside the flag.txt. So it's another variable for it to print, so we can do that. For that, let's search if there's any online exploit for it. And since this is using a global offset variable, that's also useful for us to exploit it. Payload to overwrite GOT printf string format. We have a blog post. I'm just going to open a random websites here. Okay, so this is exploiting GOT. Hmm. Exploiting a GOT override. Okay, so source exploitation. This is the binary file from. Oh yeah. What we can, yeah, this I remember. So that's a library called PWN upon, which is going to be used for basically in CT. It has a CTF framework. I can Google search that library. I guess it's a library. It's there, and Python py. Yeah, it's here. So it uses CTF. What is that? A framework. It's developed on that ideology, where you can use it for different kind of exploitations that you can do. So let's also open the documentation of it. And by default, it's not usually installed in your computer, and you can just run this code or the command into your terminal, which is going to install the whatever is required for it. In my case, it's already installed. So let's write a Python code. No, we can do that. I'll use the Vim editor. You can use any of your editors or Sublime Text or any kind of those IDEs. So exploit.py. Then I will insert here. So I'll let's go to the documentation page here, and then there's a lot of things which we can actually do using this library. So let me only search for the specific thing which I want, which is format string. Yeah, so we need to use this library for exploiting our vulnerability which is there. Okay, so let's go one by one step at a time. So from pwn import everything, then let's set the address. I'll name it as addr, which is equal to this also has another function, I guess. If I'm right, it's going to be p32, which is going to convert it to a 32-bit format. If you give any address, it's going to convert into that. So 0x, and then the address of my location which I wanted to overflow. So I'll put this here. I guess this is where the flag.txt is referred, but this is the function, not that one. Sorry, this I need to copy this one. This location is where the flag is open. Basically, that's just where the flag.txt was, the string was being referred, but this is the location where the flag.txt is opened and saved in this function, right? Okay, so the reason why I'm doing this because it's nowhere being referred that or it's nowhere being printed for any condition. If I put any limit let this be printed, nothing is happening like that. So I just want to overflow this memory address into the print functions so that when it's printing, let it print the content inside this function whatever is stored. So that's what I need to enter here. And then to get these, let's run it on our binary file itself. No? So let me name it as binary itself. Binary is equal to the location of it. So binary delete, then ELF, which is going to be for storing all my environmental and system kind of things. Like you saw all these dot, let me go down here, all these global offset table and those kind of variables what are all there, the linked contents whatever all there, so I can have them uh, put into that variable. I'm forgetting the term, but it's called as system something. Okay, I don't know the exact, or I'm not able to remember the exact term what we call it as, but that's something which it shows. I guess it's symbol. It's symbols, something like that, which we use in GDB for disassembling it and then analyzing all those things. So yeah, So ELF, and then I will say ELF. It's another function inside the PWN library. And then let me specify from which file it needs to extract all these things. This one. Then let me create a payload which I want to be entering into my file. Okay, for payload, I guess there's a function here. That's what I was trying to open here, which says payload generation, right? So for generating a payload, you need to enter this function. You need to mention this, and then five is the offset limit. After how many repetition are we supposed to be entering the values, what we'll be specifying later, into the memory or the stack address, right? So we need to mention this, and then we need to specify address and what value we need to give into the address. Do I see any examples in here? If I'm right, I just want to look at the way how we enter that one. Is it flower brackets or what is it? So I know that we need to give an address, and then what address do we want it to enter into? Um, Let me just scroll a bit. Mm-hmm. Or let's directly go here, which this might have some info. Printf, payload generation, file offset. Okay, how useful? Okay. Hmm. Yeah. Okay, so this is what a payload. Then the payload option. The we need to use that function offset limit and the flower bracket. So elf.got, which is going to say that use the global offset variable and then printf and what we need. Okay, so let me copy this itself and then paste it here. Here, let me mention my address, which is addr, and I've specified this to be elf itself, right? Okay, so that I thought it'll get some error in the later state. So then I need to close this bracket, the flower bracket, right? Yeah, I need to close the flower bracket as well as this bracket. So let's just print and then check if this is working. If not, we can modify it later, right? So let me print this, right? Then Python 3 percentage, which is going to run the tool. Okay, so we are able to get this. So this is some value being repeated 7 times. Okay, that's what I've set. I've given my offset to be 7. Oh no, I should give it as 7. No, I copied it to 5. Let's specify it here. Not 5, but 7, because that's what after 7 times of it, it started to repeat itself. Let me open another terminal and show that again. So when I run this tool, and then if I give percentage x dot percentage x dot, now let me copy this, paste it here, and you can see after 7 times of it, 1 2 3 4 5 6 7, we can see it to be repeating from the 7th time, 255 252e and those things, right? So I want to set that as my offset limit. Then the global offset table for printf, and then it's going to go with the address which I want it to be in little Indian format for 32-bit executable file. That's good. So we are able to print this successfully. So if this is done, we can just connect to our host and then exploit it. No, so host is equal to the host. Let me copy that from here, which is host. Okay, .com, and then let me set the port, no quotes, and then the number here. Okay, so there's another function called remote, I guess, in the documentation. No. Okay, so there's another function called remote, if I'm right. If not, we can even Google search that later. But have they used it here? So okay, so remote. Let's just give it a try. If not, we can Google it later. So host and then the port number. So this is specifying that let the p variable have the host being passed and the port number. It's basically we're trying to connect to it. Now let it print. Um, no, so let it send the contents. No, so p dot send line and then pass my payload. So to the remote location, I'm sending the line payload which I have, and then let it print whatever gets from that p dot reval. Okay, and then another function. Yeah. So escape, right? Then Python 3. This should give us the exploited. Yeah, it gives us an output. So we were able to connect to it, and original input gave all these things, and then wow, we got a flag. So successfully we have overflowed our memory address, which was containing the location of the flag.txt in the registry of the memory address, and then we got our flag from that. So we have overflowed that address of printf using the memory address which we already got to know, and then we overflowed it to the print function to exploit it. That's great, and we got the flag now. That's fun. Okay, so we can submit that flag. That's over. Okay then, so if you enjoyed, please do like the video, share it to your friends or person who is really interested into binary exploitation or ethical hacking or cybersecurity in general. Please share the videos and please do subscribe to my channel for latest videos and things related to CTFs and all those cybersecurity contents. So hope you enjoyed and learned something new out of this video. That's it for today. Thank you.